Good morning, folks, and welcome back for week 10 of Building Construction for the Fire Service here at Madison College. This week you're going to be looking at Chapter 9 in the IFSTA book, which deals with steel structures. And steel structures really are kind of the story of how we got to having tall buildings. And you'll see some discussion in this module about why steel is so important to keep a building light, and for that purpose, for that reason, be able to build it tall. Probably the most well-known and most tragic steel building failure in the history of the world is the collapse of the World Trade Center towers. And I've placed a video at the top of this week's materials, and I would strongly encourage you to watch it. It's a little less than an hour long. It's done by Nova from PBS. It's a very, very well executed analysis of why the World Trade Centers collapsed. And I think it's particularly salient for the fire service to understand the causes behind that. So I would strongly encourage you to watch that video as you work your way through Chapter 9. As always, you'll need to take the quiz, which is pictured at the bottom of the page here. Additionally, you need to submit the next element in your National Construction Safety Team research paper. And so we have actually gotten caught back up with the appropriate week. So you will be working out of the Week 10 folder. I will have you develop the abstract, which you would have been doing in Week 9, actually at the end at the completion of your paper. Basically, what you're going to do this week is you're going to submit graphics in this template. And this template's just a Word document where you're going to paste in graphics that you think that you might use for the explanation in your diagram. One thing to think about for your report in terms of developing graphics, I think a really simple and kind of low-dollar way to do graphics is just simply to use PowerPoint. So if you take PowerPoint and you insert a new picture, so if I just go and find a picture here, you could take these pictures out of the NCST report, you could take these pictures off the internet. Just make sure you cite your source appropriately. And let's find a good picture here. So here's a picture of this structural collapse. You can bring this into PowerPoint, and the nice thing in PowerPoint then is that you can add elements to this picture, such as you could diagram with arrows and labels, which I'll show you here. So I'm going to insert shapes, and for instance, if I wanted to draw an arrow pointing at this region of the picture, I can draw that arrow in. I can manipulate the arrow. If I click on it, if I right click on it, I can format it, change its weight, and change its color, change its end type. Let's make it red so it stands out. So the idea being that you can bring photographs in, you can label them, you can crop them, you can draw diagrams that indicate how forces are moving through structures. We really want the pictures to tell the story, which is commonly the case with engineering problems, is that the picture is better than the verbal description anyhow. When you're done, when you've got that accomplished, you can say Save As, and you can actually save this slide as a file, as a picture file, and I would save it as a JPEG. I think that's probably the most universal. And I would say Save, and in this case it's going to ask if I want to replace the same. I will say no, but I would give this picture a name, bricks with arrow or something like that. And through this process I can assemble a number of pictures that have arrows, labels, things of that nature for the report. Again, it's important that underneath the picture you would list the source. So if you took this from the NCST report, make sure you cite that. If you took it from a particular website, cite the website that you took it from. So once you've assembled all of your graphics, basically you can just click on the this link. It will ask you to submit a file, and you can send the graphics in. And at this point you're just pulling together pieces that you'll use later as you write the report. The last thing I want to discuss today is kind of the analysis process that you will use in the coming weeks on this paper. I've included in today's announcement email a link to a voice thread that I did that discusses a chapter in the textbook that we use for the face-to-face building construction class. And I think it does a good job of getting down to kind of root causes of construction failure. But I want to talk briefly about cause analysis so you folks know what's coming. So I want you to imagine a scenario in which a person slips and falls in a factory and breaks their leg. So if we think about the timeline of the event, we have this kind of line here, and if time's running from left to right, this is the event. This is the person that falls down and breaks their leg. Now, after the event, if you get over here, this is what Gordon Graham would call Lawyerville. If you think about after the event, what can we do? All we can do is try to fix things. We can try and decide who pays, right? So bad things happen over here. We end up paying money. Our organization could be embarrassed. You know, if we burn down half of the neighborhood because we didn't know what we did, that would be a bad thing. Nothing good happens to the right of this line. Before the event, there are a number of steps that lead up to it. Over in here, this is the purview of people we call risk managers. And of course, our goal is always to work on the left side of the line where the risk managers work. We want to prevent the event. If the event happens, nothing good is going to come out of it. So I want you to think about a scenario where a person falls down and breaks their leg. Ooh, leg's broken in a factory. Okay. Well, why did that happen? Well, it turns out it happened because there was a puddle of oil on the floor. So, you know, we could think about, well, I'll just abbreviate. PFD is this is what we'd call the proximate cause. Person falls down, or maybe I guess the event would be broken leg. So what was the proximate cause of the broken leg? It was the person falling down. Or another way to think of it is you ask the question, why? Why did the person's leg get broken? Because the person fell down. So we ask why. Well, why did the person fall down? Well, because there was oil on the floor. So we ask why. There was oil on floor. Well, why was there oil on the floor? Well, it turns out that there's this overhead conveyor up here, and this overhead conveyor belt is dripping oil out of the gearbox onto the floor. So we ask, why was there oil on the floor? Well, dripping conveyor belt. But why was the conveyor belt dripping? Well, it turns out the maintenance people who serviced this had the wrong tool. Well, why did the maintenance people who serviced it have the wrong tool? So you can see what we're doing, right? We're asking a series of why questions to try to get to the root cause. And there are people who will call this the 5 why process, the idea that you really don't understand what happened until you've asked why 5 times. Well, it turns out that they had the wrong tool because there's no budget for tools. But why is there no budget for tools? Well, it turns out that at the Harvard MBA program, where the management of the factory went to school, that they don't emphasize the importance of maintenance. And so there's no tool budget because the person running the factory doesn't think that that's important. So the Harvard MBA caused the lack of the budget. Now, you know, could we keep going? Sure. You know, you could ask, well, why doesn't Harvard teach the importance of maintenance in their MBA program? You could go forever. But the moral of the story here is you can see we've created what IFSTA calls the chain of causation. And if you think about trying to prevent this accident from ever happening in the future, all you have to do is break one of these links. So, you know, what could we do? Well, we could clean up the oil on the floor, right? That would make this problem go away. Of course, if this conveyor belt is still damaged and still dripping, an hour later we're back to the same problem. We could fix the damaged overhead conveyor belt. Well, that fixes the problem until the next time that it's got to be repaired or serviced again, and then the next time the maintenance people service it, you're going to be right back to the same problem. We could buy the maintenance people the correct tool. Well, then the next time that the maintenance person services this problem will never happen again. But if this happened with this conveyor belt, there are likely other things in the factory that aren't being done correctly because there isn't a tool budget. We could give the maintenance people a tool budget, which would likely prevent that. And that approach is going to last probably until the current management leaves and new management comes in and doesn't see the purpose for the tool budget, and then axes it, and we're right back to square one. Or we could go to Harvard and we could talk to them about their MBA program. But that's probably not very realistic. We don't have the resources. So if you think about these interventions, you can think about like interventions close to the event tend to be cheap, small amount of dollars, but they don't tend to last very long, right? Time is pretty short. So you're looking at this compromise. If you think about going and fixing the MBA program at Harvard, well, that's going to fix this thing permanently. Time, it's going to last a long time, but it's also going to cost a ton of money to affect that kind of change. So you're looking for a place along this continuum that's a good place to change the approach. And maybe the best compromise is we fix this, we break this link in the chain, we establish a tool budget. So this process, this 5 whys process, is what you're trying to do as you analyze the NCST report and look for root causes of the building failure. You know, the building may have failed because the bricks crumbled, but why did the bricks crumble? Well, because they weren't maintained. Well, why weren't they maintained? Well, because the building's not in an economically viable part of town, and there's no ordinance that requires maintenance. You get the idea. You're trying to figure out kind of the most cost-effective way to deal with the root cause of this. One other final comment on this. This is worth doing some research on your own online. There's a diagram called a fishbone diagram that can help you kind of diagram out all of these what we'd call proximate causes, the causes closest to the event, contributory causes, those are the causes that are kind of medium distance from the event, and root causes, those are the most fundamental causes. And in this fishbone diagram, basically these first branches are what you'd call proximate causes. And then for each proximate cause, because there may be more than one, you would break it into contributory causes, and then each of these contributory causes could get broken into root causes. So that on each of these lines you'd be writing here a proximate cause, here a contributory cause, here root causes. Again, we're just trying to get down to really what is the problem before we try to solve it. Again, I've included a voice thread that explains this in some additional detail in the announcement. And as always, if there's anything I can do to assist your learning, please feel free to get in touch with me at the contacts listed in the course syllabus.